All right, pipsqueaks and pumpernickels. Yes. Here we go. So, guys, today's lesson, we're still on the quadratics unit, is solving quadratics using taking the square roots, okay? So, muy importante, I want you to write above ax squared plus bx plus c, reminding us of the standard form of a quadratic. Why is this important? Because you guys need to recognize the different kinds of forms of quadratics you're going to get on the Algebra EOC, okay? You'll either get it, as a trinomial, or you'll get it as a binomial, the difference of two perfect squares, or a perfect square trinomial, or you'll get it as, four terms where you have to solve by, factoring by grouping or factoring completely. But here we have a quadratic with only two terms, and there is subtraction here. So I don't know if you were tempted when you looked at this to say, oh, this could be the difference of two perfect squares. Good guess, but 3 is not a perfect square, and neither is 75. 75 is not a perfect square. But what I want you to know is how you can recognize when you need to solve a quadratic taking the square roots. Okay, put a star. There is no B term. Okay, put a bubble, put the star, put the exclamation marks and the smiley face. That is your clue. That is your hint, okay? Right here, we have our A term, which is 3x squared. We have our C term, which is a negative 75, but we do not have our B term with our variable x, our bx. We do not have our B term. That is your clue, that is your hint that you can solve, that you need to solve this quadratic taking the square roots. So everyone circle this x squared because there's only 2 steps. Circle it, do it now. You're writing it as I'm writing it. So step 1, I want you to isolate the x squared, okay? Get that x squared all by itself. We're basically solving for x, you guys. That's all we're doing, okay? But I just want you guys I want to break it down in this way for you. Isolate the x squared, which means what? We need to get this x squared all by itself, which means we need to move what to the other side? You have to move the negative 75 to the other side. You have to move the 3 to the other side to get this x squared all by itself. So how do we do that? By doing the opposite of what it is, okay? So what's the opposite of a negative 75? Positive 75, yep. Those cancel, bring down your 3x squared equals 75, okay? Now, we still have not isolated the x squared yet, okay? So now that's 3 times x squared. We got to move the 3 to the other side. What's the opposite of 3 times x squared? Divided by 3. So we're going to divide by 3 on both sides. Bring down your x squared, okay? And 75 divided by 3 is 25, okay? So guys, we are solving for x, okay? That's the goal. We want to say x equals something, okay? Have we solved for x? No. That's x squared. That's not x. That's x squared. So we have to somehow get rid of that x squared. How do we do that? By doing the opposite of what it is. What is the opposite of x squared or something squared? Taking the square root of it. That is the opposite of something squared, okay? Taking the square root is the opposite of x squared. And whatever we do to the left side of the equal sign, we also do to the right. And what happens here, that squared cancels, the opposite operations cancel each other out. We bring down our x, and now I'm going to talk to you about what it means to take the square root of something, okay? We know that when we're taking the square root of 25, we're asking ourselves, what times what gives us 25? Well, you should say 5 times 5, okay? But what is the other possibility, you guys, okay? The other possibility is negative 5 times negative 5, because a negative times a negative gives you a positive 25. Okay, so that's why in your answer, when we're taking the square root, everyone put the star here, you have to write the positive and negative symbol with your answer, because the answer could be a positive 5 or a negative 5, okay, for your answer. So, oh, sorry guys, step 2 would be write this down, take the square root, okay? And then, guys, don't forget, okay, circle that positive and negative symbol right there, okay? Don't forget the positive and negative symbol with your answers, because when you're taking the square root of something, okay, we have to account for the positive and negative side of the number line. So even if you get a decimal, decimals are totally fine, okay? So let's do one more example while we're recording. Okay, and then we'll close this out. All right, so take a look here. I want you to look at B, and I'm going to make it larger. Go ahead and write this down, because I want to show you what could possibly happen as well. So everyone write down 3x squared plus 15 equals 0, okay? So again, the goal is to isolate the x squared and then take the square root, right? So we have to move that positive 15 to the other side. So we're going to subtract 15 from both sides. Those cancel. Bring down your 3x squared equals negative 15. Okay? We still haven't isolated that x squared yet. We have to divide by 3 on both sides. Those cancel. X squared equals negative 5. Okay? So we haven't solved for x yet. That's x squared. That's not x. That's x squared. So at this point, we would have to what? Take the square root. So here we go, you guys. Take the square root. And whatever we do to the left side of the equal sign, we also do to the right. Bring down your x. Now, guys, here is where you would stop. Everyone put a big, huge X, and we would write no solution. And you don't need to go any further. And let me tell you why. Okay? You guys, we can never have a negative number, okay, inside the radical here, okay? That would have to be simplified with imaginary numbers, and that's, you know, algebra 2, and that's not what we're doing this year. So all you need to know is that if you take the square root from both sides and you have a negative number inside of that radical, you stop right there and write no solution, because you can't go any further, because there should never be a negative number under the radical sign, okay? And that's solving by taking square roots.